gentlemen, it's the 1 second hot warm air blower, intelligent, power saving, no light and low noise. Maternal and infant access is available. Welcome back to the wonderful world of dubious engineering. Here's something sort of cool. It's a heater from China. No coverage, it says on the top. It has a little safety switch on the bottom of it, so if it falls over on its face, it turns off. It has a little rotating turntable on the bottom of it, and it has capacitive touch sensors on the top of it. So what I've got here is an 1800 watt continuous rated sine wave inverter. I've got this heater plugged straight into the sine wave inverter through a 240 volt main socket, and on the left hand side of all of this there are batteries, banks and banks of 115 amp hour AGM 12 volt batteries, and then there's a solar charge controller on the top of it all, and there's a couple of girt solar panels outside. So now, without further ado, let's switch all of this lot on. It's going to get noisy rotating. In fact, actually, it's not on a very good surface for rotating at the moment. It's likely just going to sort of walk its way off and fall on the floor. This is actually the one thing that's a little bit worrying, is there is a cable poking out the back of it, and in rotate mode, if you're not careful, that cable gets fouled up, and the heater has a tendency to sort of walk around and fall off stuff. Try it again. Turn it on, rotate mode and fan mode. Come on now. By the way, I apologise if it sounds like I've got a bit of a blocked up nose. For 3 weeks now, this is the reason why I haven't made a video for a while, but for 3 weeks now I've been horribly sick, and so has my wife, bless her cotton socks. Right, there we go. That was the end of that rotation. So now hopefully we should see a full oscillation, or it's not a full oscillation, it's more like about 90 degrees. Anyway, tell you what, let's just have a quick look here. ProSine inverter says that we're at 12.8 volts and we're drawing about 1 or 2 amps at the moment, which is sort of fair. So let's actually switch on a bit of heat here. You can hear the sine wave inverter firing up, and all the fans are now starting to whir in the sine wave inverter. Bit of luck here, you can see the current consumption starting to rise up in the sine wave inverter. If I put my hand in front of here, oh, that's lovely and warm. That is actually really quite pleasant. So this is currently on half power. Let me get a thermometer. Right, what we're looking at. So yeah, so 660 or 70 degrees coming out of that little heater, and we are drawing approximately 72 amps at about 12 volts. So we can do a little bit of mathematics there and figure that out. I think it's about 820 watts. So all efficiencies and everything, this is currently drawing about 820 watts. Let's turn it up to its 1.2 kilowatt setting. And straight away on the inverter here, we can see obviously there's a little bit of voltage drop there as we're drawing more current, and the inverter is showing us that we're now sucking about 110, 112 amps. And actually this heater is now visibly, I can definitely feel, oh yeah, there we go. So let's just get the camera in the right place. We're looking at about 120 or so degrees. Actually, I'll just put that back on fan only mode, which is just sort of cool down, let everything cool down. It just blows things away. And let's turn off the inverter. Ah, there we go. It's all nice and quiet again now. So all of that said, that little heater right there could quite happily live in the camper van and be used in the camper van, even perhaps with a couple of AGM batteries and some kind of sort of like 600 watt continuous rated inverter, maybe a 1 kilowatt inverter. That actually could work in the camper van as a little emergency style heater, you know, for those evenings where it's particularly cold. Yeah, interesting concept. Anyway, let's pull the thing apart and see what it looks like inside. Yeah, screws. These that's a feeble looking little screw, isn't it? I thought these were going to be great big solid screws, but they're yeah, oh my goodness, they're really really tiny. Yeah, anyway, let's get all the screws out. Come on. Oh, yeah, there we go. It's coming apart. Oh, yes. Check it out. Okay, right. So, yeah, the front just comes straight off. This looks to me very similar to a microwave turntable style motor. But strangely, yeah, there's a little micro switch in there which reverses the direction of the motor. So that's that. Oh no, sorry. No, I lied. Yeah, the motor must just be purely mechanical. There's no switch in there. It's just two cables there for the motor. But there is a micro switch in there, and the micro switch is the tilt switch. Never tilt the pinball machine, but ultimately the tilt switch, if the unit falls on the floor, then the tilt switch operates. But let's have a look at this. There's what looks like a bimetallic strip up in here. Oh, this is going to be fun. Come on, let's get the camera on ground level. There's even a little infrared device here. It looks as though I should have had a remote with this, but I didn't get a remote with it. Come on, let's get into this. This is going to be good. Move all of that lot over there. I'm never going to remember where all these cables go. Come on, there we go. Right. Oh, we're going to do it. We're going to do it. Yes, we are. Lovely. Check it out. Hopefully at the top here you can see what is a bimetallic strip. And ultimately the way this works is there's a temperature differential that will mean that one of those pieces of metal will move more than the other piece of metal, causing them to disconnect from each other. When they disconnect from each other, that means the heater will turn itself off. When they reconnect to each other, the heater will turn itself back on. So that's a nice little safety feature in the heater there, stops the heater from getting too hot. What I love about this heater is the fact that it is actually two 600 watt heaters that are connected effectively in parallel when you set it to the 1200 watt mode, which means that you're not PWMing this heater. There's nothing in here. It's just literally a heater that's just turned on flat out at 600 watts. And then if you want 1200 watts, you turn the second one on. And they're all running in parallel, and you can see a bunch of cables here all connecting up to the different heating elements and all the rest of it. Let me just grab the circuit diagram. So in the very flimsy single piece of paper instruction book, you can see here what looks like a circuit diagram. And yes, indeed, you can see here two heating elements connected in parallel there. There's a temperature control and a thermal fuse. Perhaps that's what they're referring to with the bimetallic strip at the top there, the thermal fuse. And then obviously there's a fan in connection with live and neutral as well, and an on-off switch, and various other bits else as well. But I mean, yeah, very, very sort of simple single piece of paper instruction manual, but you know, it tells you what you need to know. It tells you that there's two 600 watt heaters in parallel, which is quite cool. So underneath the heating elements, we have what looks like, wow, that's a 12 volt DC brushless fan for perhaps a power supply. So this here then is the electronics, the capacitive touch sensing switches, and control circuits for this particular unit. And yeah, there's an IR LED here. With my kit, I didn't receive an IR interface, but on the box it did show that you can get an infrared interface, but sadly that didn't come in my box. So yeah, that's a bit of a shame, isn't it? Anyway, let's have a look and have a quick look. The thing that I'm keen to see is, what are these capacitive touch sensors made out of? Let's have a quick look. It's a whole load of Zebedees. Boing, said Zebedee. Yeah, so ultimately we've just got a whole bunch of spring-a-ding-a-dings on the top of here, but everything ultimately is just sort of done in electronics. There's a couple of relays at the top here, and this will be some kind of voltage switching circuit to get us from 240 volts down to 12 volts. On the back of the PCB here we have some kind of a dual inline IC. But yeah, it's a really sort of simple circuit, all things considered. Certainly, we've got spade connectors on here as well. And the other thing, it's really quite funny. These are twist-on crimps. So ultimately, you twist You twist the wires together, you shove them all inside here, you screw that in place, and then you give it a squeeze with a pair of pliers. Yes, some really, really good connections going on in here. But yeah, what a lovely piece of kit. I'm going to reassemble this, and we're going to put it in the van. I'm going to enjoy making use of this. The thing that I really love about this piece of kit is it is 600 watts continuous, 1200 watts if you engage the secondary set of coils or secondary set of windings in the heater here. But 600 watts is a nice sensible number for a fan heater. Ladies and gentlemen, thank you ever so much for watching. Take care, have a wonderful, wonderful week and weekend. We'll catch you in the next video. Cheers and beers. Bye for now.